I will evaluate the integration of this rational expression by partial fractions. Let me first take out the rational expression so that I can resolve it into its partial fractions. Note that this is a proper rational expression in that the numerator has got power 2 and that is less than the denominator, which is of power 3. So observe the denominator, which is made up of a linear part and a quadratic part. So I'll resolve it into two separate or two smaller rational expressions with a linear denominator and a quadratic denominator. So when you have a linear denominator, the numerator will be a constant. When you have a quadratic denominator, the numerator will be linear. Now our task is to solve for a, b, and c. So since we have a linear denominator here, I can use cover-up rule to find the value of a. So to find a, I will copy the rational expression, but I will cover up s. Whatever I covered, substitute to be 0. So I have an 8 over 4, which is 2. Now to solve for b and c, I will have to compare coefficient. So let's first get rid of all these fractions by taking the denominator and multiplying across. So now I'm going to expand by distributing this to this fraction as well as this fraction. So first fraction multiplied to this term, can you see that s and s will cancel? So I'm left with this. Second fraction to multiply to this term, can you see that s squared plus 4 will cancel with s squared plus 4? So I'll be left with this. Expand completely. So now I'm going to compare s squared terms. Look for the s squared term. So if I were to look at this term, the coefficient is 3. If I were to look at this term, the coefficient is a. And if I look at this term, the coefficient is b. So since I know that a is equals to 2, I can replace the value of a here and find that b is actually equals to 1. I'm now left with finding c, so I'm going to compare s term. So if I look at this, the coefficient of s is negative 1. And here the coefficient of s is c. So I have found the value of c. So I have my a value, which is 2, my b value, which is 1, and my c value, which is negative 1. I'm going to put it back into my partial fractions as well as back into the integral. So I've resolved this rational expression. I'm going to take all this with the values of a, b, and c and put it back. We have a over s, where a is 2. We have bs plus c, where b is 1, and c is negative 1, over s squared plus 4. I think I can integrate this, but this one perhaps I will break this fraction up first. Integrating 2 over s is easy. It's just 2 ln s. Now this is a little bit tougher, but if you can see, when I differentiate the denominator, I get the numerator. So recall that if I were to integrate a reciprocal function where the numerator is the differential of the denominator, then I get simply the ln of the denominator. Which I'm going to apply here. If I were to differentiate the denominator, I should have 2s. So I'm going to multiply by 2 and divide by 2. Hence what I have here is the constant factor half, and this now looks like this form where I have the numerator is the differential of the denominator, so it's simply ln of the denominator. And this, now let's recall that if I were to integrate 1 over x squared plus a squared dx, the formula is 1 over a tangent inverse x over a plus c. So if I were to do a 1-to-1 matching, I can see that instead of x, I have s as the variable. Instead of the constant a squared, I have a 4, which means that the value of a is 2. So this part becomes 1 over a, which is 1 over 2, tangent inverse s over a plus c. That's the answer.